Okay. Hi, everyone. My name is Angelica. I am in group 5, and today we are going to be solving an unknown compound based on 3 different graphs that were given. Today we're going to be observing the compound C4H6O2, and we will be looking at its IR spectra, the carbon-13 NMR, as well as the 1 hydrogen NMR. And we're going to be using the data to find out what the unknown compound is. So let's just get right into it. So we're initially going to take a look at the IR spectra. We can see that at or between 2900 and 3000, there is an sp3 C to H bond. We can also see that there is a carbonyl or C double bonded to oxygen at 1780, which is higher than where we would see a ketone stretch. So we know that this is definitely not going to be a ketone. Additionally, moving on, we can see that there is a carbon-carbon bond at 1400 and a carbon-oxygen bond at 1170, which refers to an ester. We can also tell that there is no broad alcohol signal anywhere, so we can tell that this is not going to be an alcohol. This is definitely not going to be a carboxylic acid or a ketone. So moving on, we can take a look at the carbon-13 NMR. We can see that there is a signal at 180 parts per million, which strongly corresponds to a carbonyl. We did see that in the IR spectra above that we saw a carbonyl signal as well. So we know that that confirms that there's definitely going to be a carbonyl. Then we can move on over and see that at 70 ppm, 29 ppm, and 22 ppm, there are sp3 carbon hydrogen alkanes. So we know that there's going to be 3 CH2s involved in our structure as well as a carbonyl group. And if we take a look at our So we'll zoom in here first. If we take a look at the 1 hydrogen NMR, we can see that there is a triplet at 4.3 ppm with an integration of 2H, as well as another triplet at 2.3 ppm with an integration of 2H as well. And lastly, we have a quintet at 2.1 ppm with an integration of 2 hydrogens as well. So there's basically 3 different environments, each of 2H integration. 2 of them are triplets and one of them is a quintet, as I mentioned before. So this strongly suggests that there is a CH2, CH2, CH2 bond, as I mentioned just before with the carbon-13 NMR. And then the last remaining group would be the carbonyl or the COO bond. And then if we move on over to the tables and calculations, so we know that the molecular formula is C4H6O2. If we want to calculate the degrees of unsaturation, the formula would be 1/2 times 2 carbons plus 2 minus however many hydrogens there are minus X, which stands for the halogens, plus N or for nitrogens. So we ended up inputting the numbers as 1/2 times 2 times 4 plus 2 minus 6, which ultimately gives us a number of 2 degrees of unsaturation. So therefore, we know because of the degrees of unsaturation that the structure can either have 2 double bonds or 1 triple bond or 1 double bond with 1 ring. So if we go down to what our proposed structure is, based on all of the information that we looked at from all of the tables and the graphs, the final structure is gamma butyrolactone. And we can see here that there is a double bond and 1 ring, as we suspected earlier when we calculated the degrees of unsaturation. So this has 86.9 grams per mole, and it does have a few hazards such as oral toxicity, eye irritation, and organ toxicity if ingested. This compound is mostly used for industrial reasons, such as an industrial solvent. It's also used as a cleaning agent, and it is used as a binder in cosmetics. So, based on the data, we have identified our unknown compound. Thank you for watching.